Hey guys, welcome to this explainer. Today we're going to figure out exactly how the entire digital world links up. Let's get right into it.
So look around you. You've probably got a smartphone in your hand, maybe a laptop open or a tablet nearby. But have you ever actually wondered how all these devices talk to each other in a network? Just imagine them floating around, connecting totally at random in this invisible web. I mean, that would be completely chaotic, right?
Section 1. What is network topology? Luckily, it's not just a messy, random cloud of devices. Computer scientists actually organize things into super neat, structured patterns using something called network topology. Simply put, a network topology is just the shape, diagram, or arrangement of how devices are connected in a network. Think about how your teacher sets up the computer lab at school. They might put desks in rows facing the front or maybe in little clusters for group work. Network topology is literally exactly that, but for the cables and invisible signals connecting all our tech.
Section 2. 3 main network shapes. All right, let's dive into the 3 foundational blueprints used to build networks. First up, we have the bus topology. With this one, all the devices, the servers, computers, printers, the whole shebang, share one single main cable to send and receive data. It's kind of like a single highway where all the digital traffic travels. But there's a pretty huge catch. If that one main cable fails or gets damaged, the entire network just stops working. To keep a bus topology from totally crashing, we use something called a terminator. These live at the very ends of the bus cable, and they act exactly like a sponge. They absorb the data signals so they don't bounce back and collide with other data. Because, no bouncing means way fewer data crashes. Next up is the ring topology. This one is super cool because it shows how data can travel in a continuous loop. Every single device is connected to exactly 2 other devices, making a perfect circle. Data flows in one direction, passing through each device one by one until it hits its destination. So every device plays a part in passing the data along, basically like a digital game of hot potato.
Now for the absolute most common one you'll see today, the star topology. You're probably using this at school or at home right now. In a star network, every single device gets its own dedicated, separate connection that points inward to a center point. It literally looks like a star. And the best part? Because everything connects separately, if one cable breaks, the rest of the network is totally fine and keeps working perfectly.
Section 3. Essential network hardware. So we know the shapes, but what actually sits at the center of that star? Say hello to the network switch. This is the piece of hardware sitting right in the middle of a star topology, and it connects devices together on a local network. Its entire job is to manage communication. It takes incoming packets of data and directs them exclusively to the correct destination device. It's basically the ultimate traffic cop for your classroom's computers.
Then we have the router. While a switch connects individual devices together, a router connects entirely different networks together. So if you want to send a message from your laptop to a website server halfway across the world, your router finds the absolute fastest route to get that data out to the internet. It's super crucial to understand this difference. A switch connects your local room of devices together, but a router, that connects your entire room's network to the outside world. Switch equals local. Router equals global. Simple as that. Section 4. Scaling up. LAN versus WAN. Speaking of local and global, let's zoom out from a single room to the entire planet.
Check this out. A LAN, or local area network, is a small, local network. Think just a single school building or an office. But a WAN, a wide area network, connects devices over massive geographical distances, like across whole cities or countries. And the biggest WAN in the entire world? You guessed it for sure. It's the internet itself.
Section 5. Ready to connect. All right, guys, you have absorbed a ton of awesome computer science knowledge today.
Let's do a rapid-fire recap so this really sticks. 3 topologies. Bus is one shared straight cable, ring is a circular loop, and star is where everything connects separately to the center. 2 hardware pieces. The switch is your local traffic cop, and the router is your fast-pass gateway to the internet. Finally, network sizes. LAN is small and local, WAN is huge and wide. If you take away just one big picture idea from this explainer, make it this. Network topology is simply the brilliant design behind how all connections are built. It's the blueprint that literally makes our modern digital lives possible. Understanding topology is what helps network engineers build faster, smarter, and way more reliable networks. So next time you connect your phone to the school Wi-Fi, I want you to ask yourself, what invisible shape is carrying my data right this second?
And even crazier, what kind of topology are we going to need to build the networks of the future? Thanks for hanging out. Connect smart, design better, and I'll catch you in the next explainer.